Lovely to meet everybody. So we will start with sort of a brief introduction of your organizations, the companies you work with, and we'll start there, and then we'll get into the nitty-gritty of what is VPP and why is it so hot right now. So maybe we'll start with you, Brent.
Sure. I'm Brent Harris, Chief Operating Officer and founder at Iguana Technologies. We're a manufacturer based in Calgary. We make energy storage systems and sell them as part of a full fleet of power control technologies and aggregation software to deliver solar and storage systems for homeowners and then aggregate them into fleets for VPPs. I'll talk about our operations in Germany, Australia, and the US, where we're doing all these things differently in each one of those different markets.
Hans?
Yes, Hans Stegeman. I'm heading a cross-border grid innovation team at TenneT. TenneT is the largest TSO in Europe and the first and only cross-border TSO. So we are responsible for the Netherlands and Germany and located very strategic at the North Sea. A TSO in Europe is responsible for transmission, for planning, building and maintaining the high voltage grid, but also for system services. So we are maintaining the balance between supply and demand. So we are the custodians of the 50 hertz and also market facilitation. So we facilitate the market that we have a smoothly and efficient market system. Yes, and very excited to be here because on first glance the challenges look different if you look at Canada and in Europe. But yeah, we have more or less the same opportunities. The technology is already there, but it's really also the people that will make it happen. So also awareness is very important, I guess. And we really, really need this decentralized flexibility to keep the system up. And I also, we just learned from the prosumers in the other panel discussion. I think this is also a target picture, but it's also a incremental transformation towards that. And that's where also the virtual power plants can play a very important role.
All right. I'm Hamid Zaripur. I'm a professor of electrical and computer engineering at the University of Calgary. My area of research is on applications of mathematical optimization and artificial intelligence in optimal operation and planning of smart grids. Mainly, I am working on forecasting, analytics, uncertainty modeling, and optimization models for running battery energy systems, hybrid energy systems, solar, wind, those type of things. So I met Dan Earhart, CEO of Arcus Power, in 2018 in DEC, in this conference. And at the time, Arcus was probably a 2% company, Dr. Mike Kwashi and Arcus, and that's how our collaboration started. And now I have the pleasure of serving Arcus as a senior advisor, technical advisor, mostly on the analytics and data side. University of Calgary has been ranked as the top startup maker of all Canadian universities 3 years in a row. So this is a paid advertisement by the University of Calgary.
Yeah.
So I know that most of you, many people who come to this conference are not from big established utilities. So if you are a startup companies, come to us. We have myself and my colleague, Dr. Mustafa here, and happy to entertain if you have research needs and development needs. Thank you.
Also, we're all about self-promotion, especially Calgary. It's a wonderful place to be. So thanks, Hamid. So, and connections matter. Yeah, you didn't think this time last year that you'd be sitting here as an advisor to Arcus. So you're a prof. Can you explain to a layperson like me what is a VPP?
Well, a virtual power plant, if you ask different people, they will give you different definitions.
Okay.
But essentially, it's a combination of resources that can provide energy services. whether it's kilowatt services, i.e. preserve and ancillary services, or kilowatt hour services, which is literally injecting energy. It could include a bunch of homes with solar panels to all the way a whole big town with solar panels, batteries, electric cars, HVACs, thermostats, whatever that you can control and you can aggregate. I would say that most of a VPP is about the software and control and intelligence layer on top of for the most part, the existing hardware that we have. Of course, there are needs for hardware in several places, but think of it as a facilitator, as an orchestrator of some resources that can provide services if there are opportunities for financial or environmental benefits.
Han, would you agree with that, or are you going to have anything?
Totally agree.
Totally agree, good.
I don't want to ruin this. Maybe to add one thing, that it's not limited to a geographical area. It can be.
Okay.
Yeah, absolutely.
Yeah.
So it could be distributed across countries?
Yeah.
Yeah, okay. Great.
Of course, if
Yes.
just to add, if there is enough interconnection and if there are physical infrastructure to support different regional. Like in Alberta, we are connected to BC and to the south and to Saskatchewan, but we can do definitely things cross-border and also within Alberta.
Great. Anything to add, Brent? And how does a prosumer fit into this picture as well?
Well, the prosumers are key participants in VPPs right now. Generally, they're the owner of the asset. What I'd add is, yes, it can be across any range of geography, but it has to be in one market. And the real idea of the VPP is to aggregate these systems together and present them as one asset to the utility or the regulator or wherever you need to present it in that particular market as a single megawatt scale asset versus smaller assets. So that aggregation is key to it, and you could have multiple VPPs operating in one area, kind of overlaid over each other. It's not geographically constrained, as you mentioned. Each one could be delivering different services, or one VPP could deliver one service today and another one tomorrow, or use half the fleet for demand response and the other half reserved for frequency regulation. It's flexible over time.
So for you, Brent, so why is it happening now? Like, what has happened in the either regulatory environment, technology?
I think there's a lot of things happening to bring it together. We founded our company over 20 years ago and licensed our technology working with RWE AG, is a large German utility, around fuel cells, so hydrogen as the storage medium, and RWE was going to network these systems together. And I don't know that anybody had a really good idea how they were going to network these systems together. Is maybe we'll use the meter communication infrastructure, let's figure it out. Along the way, we had Google and Apple come out about 10 years ago saying they were going to manage all the energy in the homes, and everybody started gravitating toward that. That went away. And now you have the Internet of Things there, and I would say that's really the main reason is the development of that. You have very fast, reliable, low-cost communication and secure that's allowing a lot of this to happen. And of course, lithium batteries.
Oh, lithium. Okay, interesting. Do you have something to add to that, Han? Why now? What are you seeing trends in Europe or globally that would make this?
Yes,
now?
if you look in Europe, the energy transition last year, due to the war in the Ukraine, turned into an energy crisis. We saw energy prices up to 1,000 euros per megawatt hour. And it was also a catalyst for the energy transition. So a lot of households, but also the industry, accelerated in electrification of transportation and heat. And this is now a burden for the grid. So we need this decentralized flexibility, and we need first that on this aggregated level. So we also, the founder, together with a lot of other TSOs in Europe of Equity, so we have this crowd balancing platform where we are moving now towards one API to, that you can do value stacking. So it's also more profitable for end consumers, but especially on an aggregated level, to do energy arbitrage or congestion management, but also for ancillary service. So it's really important because if we, and you saw that on the video, just this target grid, we did some strategic scenario planning. If you look at the target grid 2045 in Europe, we have to double, triple, or quadruple the grids, and that's simply not doable. So we need more smart solutions because there's a lot of latent, not used capacity in the grid, I think 30 or 40%. And especially if we have all these DERs in Europe, every month there is 1 billion euros of new DERs coming to the grid, EVs, heat pumps, smart appliances, and they are poorly tracked, but also heavily underutilized. My EV is now in Amsterdam Airport. I think it has 50 kilowatt hours of capacity and just sitting there doing nothing. And I learned that in the airport in the Netherlands, there are 45,000 parking spaces, and 5,000 of them are with EV. So if you have almost half a gigawatt hour of power where you can balance the grid. So that's, but what and I think it's an incremental transformation. So we will, if we don't have this transparency and open and democratic transparency of data yet, we will get there, but before we get there, we need these aggregators on this VPP level to balance the grid.
So, Hamid, this is where maybe you come in too. On the data side, we've got the IoT networks pulling in data from sensors distributed, from a car plugged in Amsterdam Airport. Huge data sources. How's that played into it?
I'm going to comment on your previous point about why now, and then I'm going to get to data. I think there is established precedent for utilizing the concepts of sharing economy to provide additional services and create new economic activity in other sectors. Like VPP is conceptually very similar to Uber or to Airbnb. So those are essentially aggregators of a small micro providers of services for a fee. And it's the same concept. So it has been around for a while. It has been tested in other places. It is doable. Well, there is a little bit of difference between, directing a taxi driver or a car owner to pick somebody from here, deliver here, versus, telling electrons to be picked up from here and delivered to here. There is a bit of difference there. But essentially, it's the same thing. So I have additional electrons, and somebody needs that electrons, or I have the potential of generating electrons or moving electrons, and somebody needs that insurance, and I can be essentially that micro insurance provider. So it has been proven. It's out there. It's being used, and it creates tremendous economic and social value. And I am actually surprised why we don't have it up and running yet. I have been a promoter of energy storage as a service, solar energy as a service, EV charging as a service. Everything we do, and we have a spare capacity for it, can be aggregated and presented, and these all can come under the same umbrella of virtual power plant. So why now? I think it's actually late, but the question is, why can't even now we can have it? That goes back to the regulation, policy, the markets, and the barriers that exist to show real value and also help people get this up and running. Like for me, to use my car as an Uber driver, it's not a huge change. I know how to drive. I know when I'm free, all of that. But when it comes to electricity, we need to go and add a lot more data-driven intelligence and autonomy to the system so that me, as a person who is not an energy expert, can participate without even bothering about all those technical details. So there is complications at the intelligence level, software level, data level that we need to help, but it's overdue. Now, in terms of data, yeah, I mean, with the 5G revolution, now we can reach literally every single thermostat everywhere. We can reach every car, every EV charger, very, very cost effectively. This wasn't possible 5 years ago. With the 5G revolution, we have cheap, very low latency, very fast access to the last 5 miles of the grid. Right? So we have that. And with AI and what is happening on reinforcement learning and all those things, creating autonomous decision making is doable if you have collecting the data and if you have the data. So we have the ability to collect a lot of data. We have the ability to control devices. It's just a matter of having software solutions and optimization solutions and AI tools that come together and aggregate them all together and provide a service as a VPP.
So yeah, I mean, it's kind of like the two-sided market, like you said, the Uber, getting people comfortable, putting that service out there and facilitating that market interaction and getting people used to that and comfortable.
Absolutely.
More so. So I'm sold. Why is this not more prevalent now? I mean, you've been around 20 years, you've been building Iguana. Like, what have you seen? Like, what's the resistance that you're finding? Or?
There's, we've gone to places where there's less resistance. I think a little bit the same thing Glenn was saying earlier. Mm-hmm. We're not going to try and change the whole world. There's places where there's more pressure to do it from mm-hmm. costs or other factors. So we've seen all kinds of models. It depends if it's a vertically integrated utility, which is most of our VPP activities right now in North America are through that, where you're delivering a service direct to the utility that's responsible for that area. Those tend to be along the lines of demand response. In Australia, the national electricity market there is a competitive market. So we're working with a retailer that's offering some incentives to their customers. They bring them in, they can tie that in with a competitive offer on the electricity as well, give them some upfront payment and then some on-bill incentive when we deliver frequency control services for them. So then we're aggregating all of that, rolling it up, and they're bidding it or presenting it back to the market that they bid into as a verification that they did what they were supposed to do. That retailer gets paid, and then the question is, how are they feeding that back to the homeowners? And right now, it's really just an upfront payment and a monthly cost. That's all really a prosumer is ready to deal with right now. We see in some of the markets in the US, they're moving to a per event payment. So now the prosumer is taking a little bit more of that risk. Is there going to be a grid event that I'm going to get paid for or not? And so they get more of the upside, but more of the risk as well. I'd say it's similar to electric vehicle charging, where are you paying by the hour or by the kilowatt hours? It depends how much you really want to think about that. So there's different models everywhere, and then, like I said, different services as well. So in Australia, we have to build the fleet up to a megawatt level before it can bid into the frequency control market. So until that time, as we deploy the systems, they're going to do demand response, energy arbitrage. We can dispatch them for other purposes. So it's just having that.
So building a bit of a critical mass in some of those markets?
There's a critical mass for those competitive markets. It's not as big a factor in the vertically integrated markets because the utility can understand what it is, but the regulator in Australia just doesn't want to think about much below a megawatt, and that's where the virtual power plant comes in, and our aggregation, we're able to determine what makes up that megawatt at any given time.
So like adopting any time, making it easier for the adopter to adopt that technology. Okay. And then communities, so you're seeing where there's a bit more urgency or there's cost factors, you're seeing spikes.
Yeah. The
energy
Australians' electricity costs have gone up 50% since the start of the year, for example. And then they have very sunny there. A lot of these systems went in on feed-in tariffs. Then the feed-in tariff ends. So instead of getting paid 50 cents a kilowatt hour, they're getting paid 6 cents. And say, well, maybe it's time to invest in a battery, save more of that power for myself during the day, so I'm offsetting my 40 or 50 cent electricity I have to buy in the evening. So that's what starts to drive it. And then the retailers and utilities want to participate in the virtual power plants. Australia is one of the only markets in the world where the regulator actually has a forecast on decentralized energy and what they're depending on those systems to deliver over the next 10 or 20 years. Versus most places, they have their system plan, and yeah, there's some decentralized energy stuff over here, we're gonna keep an eye on it, but we're not depending on that. If we have a real peak problem, that's nice, that's there, but we're not gonna depend on it. In Australia, they're starting to depend on it.
Oh, wow. So is that, I mean, talk about resiliency, I mean, the biggest fear we hear this, there's going to be power outages or there's going to be more of this kind of thing. Is a more decentralized system that you're talking about actually helping resiliency then?
It's
or contributing to?
It's far more resilient.
Yeah.
I think Amory Levins coined the term brittle power, talking about our power systems as they're designed today. They're just so vulnerable to a single event, knocking out power to hundreds of thousands of people. If we can build a decentralized system, yes, you're still going to have outages, but they're going to be smaller in scope and just affect the local area.
Okay. What are you
Exactly.
saying?
Like in Europe, we
Yeah.
are also now building this low pockets to enable to start these virtual power plants on and working together. But what's also important, and Brian already shared that, it's contagious when somebody starts with. You need the early adopters. You need to test. There's no there's no silver bullet for a solution for the challenges we are facing now. But if you start, and I think this is also very important, that with this data, you can also learn the origin of the electrons. And if there is such a thing like CO2 monitoring, it will also incentivize people to, because you don't know where the electricity is coming from. And there's a lot of greenwashing, especially with the certificates, how do you call that? The RECs, so renewable energy certificates. Do you know that here in? Yeah. But it's on a yearly base, so you can say, hey, I'm net zero. But if it's on an hourly base, and if you can really have the CO2 monitoring, and there are some pilots in the Netherlands where you can see on a block level when you reach the maximum of CO2 emissions a week or a day, and then people suddenly see this meter going, and then they think, okay, let's not shower for half an hour, but for 5 minutes or whatever. And this is also what this data can bring. Important thing is privacy. So the GDPR we have in Europe, but we also have the technology now to anonymize these data. No.
Yeah, I think that's important. I mean, I think the transparency and seeing that sort of instant effect can help. When my kids are leaving all the lights on at home and all that kind of thing. Like once you see that impact on the meter and the actual cost, so if the data can be improved. But then, the flip side of that then is the transparency, the anonymizing. So, I mean, if everything is connected and, people might know my behaviors as an individual if that isn't anonymized. So how do you deal with that in your work, Hamid, on the data analytics?
The whole notion of trustworthiness and of what we do, and also privacy-preserving mechanisms to take. We have technical solutions to deal with all those type of things. We really there has been a lot of progress in privacy-preserving modeling, distributed privacy-preserving optimization, and many of those things that, from a technical perspective, there is no problem. If privacy, in my perspective, those that we can solve technically probably are the easiest problem. Because we know how to deal them, we know, we can build tools and solutions around them. Something that probably it's more difficult to get around is the pull in the market and the ability of the market to really demand this type of services. Like, just as an example, in Alberta, electricity was selling for 2.2 cents per kilowatt hour 5 years ago, like 2018. Like, I met Glenn in 2018 when we were talking about all these things. And you know, when electricity is 2.2 cents per kilowatt hour, I mean, who is going to even think about electricity, right? Mm-hmm. And 5 years later, now it's 16. Like in 4 years later, 2022, on average, it was 16.2 cents per kilowatt hour in Alberta. So 4 years can make a huge difference in terms of what market wants. And the reason that Brent is seeing a lot more action in Australia than here, just look at how much they pay for electricity and how reliable is their electricity system compared to us. So there is a need from the market to push for these. And that would initiate startups, research, development, grants, applications, you know, hiring and training people to do this, which, you know, definitely we need, you know, yes, for Uber, probably pricing a service and distinguishing Mazda 2016 from a luxury Porsche is not very difficult to price them differently. But all all electrons are made the same. There is no luxury electron versus, you know, a sedan electron or whatever, right?
Yeah.
So we definitely, we need to build pricing tools. We need to build sizing tools, optimization tools, investment designs, and all those, and data privacy preserving methods for data collection, data shading, all those things. But that all starts from a pull from the market and the need from the market, so that these things are starting. Can we do this? Absolutely. Is it overdue? Absolutely. But there needs to be other factors to come together.
So pricing incentives, bringing more prosumers into the market, making it go viral, like, seeing your neighbors with those panels or other things, or talking amongst yourselves saying, hey, I'm doing this. This is really cool. Like in the same way when people first started taking Uber rides, like getting people comfortable then. And then for us, I mean, for clients that we have, small companies, to incentivize them to develop technology. First thing is, you know, who's going to pay for this? How are you going to make money doing this just because you can do it? So there's a lot of economic and pricing.
Absolutely.
Now, is anybody doing this around the world? Is there, you know, there's a technology piece, but is anybody looking at that? What needs to happen from the pricing, modeling, policy side?
In Europe, we are testing now these dynamic contracts, but also the contracts, non-firm and firm contracts. And it's a concerted effort of the industry, the TSOs, but also regulation. And regulation that's, even for a TSO, our primary objective is reliability. So speed and innovation is not in our DNA. So, and I think that's also for a lot of...
I hear you, I work for the government, so...
Yeah. And I really believe, so what we did last year, we created this dual operating system, Kotter, it's the run and the change. So we do a lot of tests now. So we test a lot of things. So outside, without the bureaucracy or checks and balances from this big company. And we also want to test this with the regulator in the Netherlands. But that's kind of difficult. But if you make use cases and you just test it in a certain area, this will really make things, because you don't know, it's like with innovation, you can't tender innovation. because you don't know what you don't know. You don't know what and you want to get to the new and the unknown. So, and this is what also TenneT and together with the regulator are now doing, this open innovation. Just start and ask also startups to test things. And I think this can really help.
So when you say open innovation, what is that? Is that like sort of calls for technical challenges? Or
we are not, in the past, we are just bringing up the requirements. We need this, we need a power line or a synchronous condenser, and we just give the requirements. Now we are saying we want to create this effect in 2 years. And no matter how you will get there, please tell us what's possible. And this is why you also see, especially in Europe, is where a lot of collaboration is the new competition. There's so much at stake. So people are working together, also building these digital partnerships. You can only do that by testing things, but also with uncommon partners to learn. And this is also what I hope to see and learn in these 2 days, to learn from other regions in the world what we can learn from them. And this is also an invitation to you if you want to have more information about the situation in Europe, the challenges, but also the opportunities. Please reach out to me. And there are also the colleagues from the Netherlands Foreign Investment Agency, Clayton and Andrew. And we are open to test things. So
That's great. Well, the problem is so huge. Obviously, there's room for everybody to work together to solve these problems. So for you, Brent, if in an ideal world, what would be the most pressing challenge that you have that you would like to see resolved? Biggest priority now?
I think one of the big challenges for deploying decentralized energy systems and virtual power plants is actually the deployment of the systems, the installation process. You need a skilled labor force to do this. There are lots of people around that are skilled at that. They're busy with their own lives and their own businesses. How do you incentivize them and bring them together? When you sell, just for example, in the United States, you have about a 10% attachment rate of storage systems to solar in the active solar markets. How do you get the solar installer, who's 90% of the systems he's installing is just, well, here's your electricity rate, here's your cost of your solar system, discounted cash flow, here you go. You're going to save money on your power bill, right? How do you get him to jump the chasm there and say, and actually, if you get this battery, now, we need to think about your loads and how you use electricity and what time of the day. It's kind of difficult, bring in this virtual power plant, and the utility is going to give you $1,000 up front and $20 a month. Trying to explain that to people and then get the system installed to a quality level that's actually required to run the VPP is a big barrier for the industry. So a solar installer sees a battery as a potential upsell on a solar system. It's like an accessory to the solar system. The utility sees the battery as the most interesting asset, and the solar is kind of an accessory. And then I don't need to worry about charging this battery in the off-peak time because it's already got its own battery charger built in. They're looking at it differently. If we can get the right incentive for those installers to put it in, that's going to really change things. So that's what we did in Australia. Is we had a partner company that was doing a lot of our installations. We bought them, and the next day the utility called us and said, "Let's go."
Because you'd acquired them and you could make it.
So now we
smooth it up.
It was all within our control to get all this stuff installed at a reasonable pace and with high quality installation, and they know the system's going to perform. And we're going to be there not just to support our equipment, but the whole installation process.
That's interesting. So supply side is really important. I think we're going to talk about the skills in the industry too. So not only increasing the demand, but being able to meet the supply to make those installations.
For us, I mean, that's the cost of the assets, so lithium batteries, coming down one day.
Yeah.
They're on their way down. That's a big part of it. Having the labor force to be able to deploy these systems, right? It's analogous to trying to put in a new gas turbine is going to take 3 years, or a coal plant is 10 years. You got to line up all of those people to make that project happen. This is more like a manufacturing process where you've got tradespeople and a pipeline of installations, and you're just out there building it up. That's what we need. And then the last piece is the network that we're talking about to link it all together and deliver the value.
And if I may, what Brent mentions in terms of showing the value and helping people understand, and that goes back to data and what you can data and what type of analytics you need to not only be able to look at the past and how they would use their system, also be able to tell them what would be a scenario of operation or multiple scenarios of the operation for future. So in order to get this whole thing work, you not only, from a technical perspective, you not only need hindsight data, but also you need insight and foresight. And in that domain, things are happening. You know, I'm not aware of I'm not much aware of what is happening on the policy side, and I can't comment on that. But on the technical side, what I know that there are startup and innovation-based companies all over the world, including right here in Alberta, like Arcus Power, for example, is an example of that they are building a lake of, an ocean of data, collecting data and making it accessible, and also building intelligence on top of that, so that you can look at the whole neighborhood, past behavior, and then design, okay, what would be the right incentive that they benefit and all be able to make money too. And also looking at the next 5, 10, 15, 20 minutes or 3 hours and be able to tell, okay, how solar is going to behave, how electricity rates are going to change, how the demand in the house is going to change, and how you should be positioning yourself to deal with that and save yourself money or whatever else you care. So what I'm saying is that on the technical side, I see a lot of things are happening. But on the policy side and on the economic side, well, that's something that is
that's maybe holding it back.
Yeah.
But you got your predictive analytics, obviously generative AI, some of these.
Absolutely.
We'll open up the questions in a minute, but I do have a question about cybersecurity then. So is that something that when we design these systems, we're obviously designing for security concerns? Is this? I mean, I think with power, it seems to be always a target that things can get hacked and there's nefarious people out there.
The utilities have pretty strong cybersecurity policies and systems. Generally, they never went below the substation. So you have transmission, generation, and substation covered by an IT policy. And then you just have these copper wires that go down the road and they go to a meter. And even 15 years ago, utilities still depended on a phone call from a customer to say, hey, my power's out. And they say, oh, I think we might have a power outage in this neighborhood. And when the second and third person calls them, they send the truck out. So they never had any data. So they never had a cybersecurity problem on the distribution grid. So what's happening is they're trying to bring these policies down from the top level and then working with all these basically consumer devices now that are all connected to the cloud and can change the rate of consumption, right? Even to, if you just hack into Nest thermostats, right, you could just start turning on and off all the air conditioners in a neighborhood at the same time, and you could bring the grid down that way in theory. So it's simple stuff.
Yeah, and people are getting smarter at this, right? I mean, Hans Park to Amsterdam Airport, somebody could hack into your TV that's plugged into the network. What would happen?
Exactly, yeah. So we spend a lot of effort in cybersecurity, but we don't share that. We don't tell much about it.
Yeah.
But we need this Chinese wall between IT and OT, and with this new technology, so clouds and this data, this time-stamped data, if you separate that from each other, and especially when you have enough DERs, then the grid will manage. It's like the cloud of the data cloud. The on-premise, that we have all our information on-premise, it's already history. So I also, even my bank account, it's somewhere in the cloud, and I rely on it. And it's like with all these DERs, if you have enough, this is the economy of scale, but also if you have enough DERs, it doesn't matter. It's like a television screen with a lot of pixels. If there are just a few not there, you don't see it. But you need to take care that it's not on one part of the system. Then you will get the breaking system.
Yeah.
You know, cybersecurity, as soon as you are connected to the net, cybersecurity is an issue. It doesn't matter what you're doing. Whether if you're using an app to, smart charge your car during or whatever else, cybersecurity is a problem. And I'm sure we're going to, as these things roll out, we're going to receive text messages that, hey, your neighbor is trying, is asking you to charge their car, and are you push this link to allow them? Yes. And I'm sure you're receiving. So I'm sure all of you have a lot of, money from CRA that is waiting for you to click on and get the money deposited in your account. And I'm sure that there will be a lot of power waiting for our car that we need to. So it's going to be there.
Oh yeah.
But the thing is that there are technologies that when we talk about peer-to-peer transactions, VPPs at the bottom layer, it's a peer-to-peer transaction, like Uber. Yep. I need a service, you can provide a service, and we make a transaction. Uber is the facilitator, but we do the transaction, right? So at this peer-to-peer transaction, there are technologies that can improve, like the most famous one is the digital ledger technology. Well, we know digital ledger for Bitcoin and cryptocurrency, and some of us probably lost some money in that market and are angry about it. But digital ledger is bigger than Bitcoin and blockchain. There are various technologies for digital ledger, and they have been tested, and there are research and experimentation going that when you come to peer-to-peer transactions and in these micro transactions, how can you use these low-cost distributed ledgers that can preserve privacy, protect people's security, go against cybersecurity threats, things like that. So the threat is going to be there. Technological solutions are potentially there at the peer-to-peer level, but do we have solutions that are today ready to go? Well, that's a big question.
On the peer-to-peer side, I mean, you were mentioning the electricity grid's a little different than the highway
it's
system.
A bit different, yeah.
I think there will be some of that transaction, but there's always going to be that role for the regulator.
Oh, absolutely.
In the electricity system. I think about it like a bridge could be there.
Oh, absolutely.
And the Uber driver can drive across the bridge whenever he wants, or 5 of them can go.
Absolutely.
With the electricity system, the bridge is only held up by having the exact rate of cars crossing that bridge at the right time. Yeah. If it's too few or too many, the whole system's going to collapse.
Absolutely.
And that's the challenge facing peer-to-peer, but there will be some role for it.
And that's where the orchestration of VPPs and all the intelligence that we can build on top of that comes to the picture. How can you respect the boundaries of the utility? Like, if the transformers that are in our neighborhoods, if you put 2, 3 fast chargers on them, they are going to blow up. Yeah. But do we all need that? No. Do we all need fast charging? Probably not. But the point is, how do you orchestrate what is happening at the peer-to-peer level while respecting the limitations of that bridge, the transformer, the substations, and how you can go from one neighborhood to another neighborhood without congesting the road between the two. Definitely. Yeah.
All right, let's open up any questions about, go ahead. Okay, 2 questions, make them good. All right.
All right, I've got a quick question. How can virtual power plants and the aggregation of prosumers accelerate adoption of this technology and move the grid in the direction we're looking for?
Maybe I can start. Yeah, I think it's A little bit like be autonomous but don't sub-optimize, because if you have on a higher aggregation level where you can, you have a more efficient system now because you have more DERs in that system.
Brent, you want to go?
I was just going to say, we see the prosumers as really the early adopters of VPPs that are coming out. They're going to make that investment. They want to save some money on their power bill. They want some backup power. And they offer the utility access to their system from time to time for a rate. But that's building the technology base, building the experience with it. But for the mass adoption, we see a change coming. And that's going to be the utility investing in those systems and putting them in the consumer's home and charging for a service to the consumer. Maybe it's the insurance that Glenn was talking about, or just backup power, so they don't have to, they can still have their Super Bowl party or whatever it is. We see that flip, and that's what's going to be required for mass adoption. And if we do it right, we can solve some of the equity issues that were discussed earlier as well. So once the utility's comfortable, they can make the regulator comfortable, they're going to get approval to invest in that asset, just like any other asset they invest in, and they'll get their 10, 15%, whatever it is. And that's what's going to drive the mass adoption, but we need the prosumers to kind of kickstart the whole process.
So I would look at it from a different perspective. I would look at it from the reliability of the grid. So if everybody is pushing to decarbonize by 2050, some places by 2035, so if you really want to do that, you need to rely a lot on wind and solar. And wind and solar come with a lot of variability, and they cannot provide system with inertia to maintain the frequency and voltage. Frequency and voltage are the two key sort of measures of the health of the system. So what do we get the help that we need to hold this huge system in balance? And that basically means that we need to rely on every single resource in the system to provide the support to the larger system. And that's where I think the system-wide benefit of VPPs come to the picture, as all these technologies and resources are inverter-driven. And inverters are great because you can control them however you want, very fast, very quick. This is unprecedented. In power plants, you have to open a gate and the fuel comes and the steam forms up. That inertia for speeding up or down or all of that is really slow. But we have very fast acting resources that are distributed all over the place, but we need all of them. So for me, the way that VPPs are going to help the system is from the larger, broader system reliability perspective.
Probably time for one more. It says 10 minutes, but it's really only 5, isn't it? Okay, there might be. All right, we'll do one more. Sure.
So, Hamid, you just spoke about speed. Let's talk about distance. So, as a rural Albertan and a prosumer, I would love to be connected to a group of people who would make a VPP with me. Is there a maximum distance, physical distance, that would limit, or is it just data? Is it just software?
Well, you addressed me, so I'm going to start. No, there is no limit that I can. You know, our grid, in terms of the capability to, the capacity that we have on the lines are enough to push to make that happen. I don't see any distance.
Electrons travel with the speed of light, so that's no problem. But there is, in Europe, you see a lot of co-ops, a small individual that, but not only storing electricity in battery storage system, but also heat. And it depends on which area you are. But this is also working very contagious, because you start as a community and you have the same definition of value for the system, so that can also help.
I'd say, depending on where you are, may affect and how far you are from other parts of the grid, the type of services that have value. So some of the services, demand response, frequency regulation, are system-wide. It does not matter where you are on the system, you can offer that service. But for example, we're doing a project with a utility just to the west of here for an end-of-line situation where they have a lot of sag through the winter months because that's their peak load. By putting some storage systems there, they can basically eliminate that peak and bring that line voltage up. That's not a service that's of high value in the lower mainland, for example. That's all I'd say about that.
All right, well, standing up. So any final words before we close? Last chance, last call. Brent, anything?
I think the last thing that we didn't talk a lot about was all those different services, and they'll have value at different times. And I think as we deploy the infrastructure, you want to make sure that the equipment and the assets that are going out there are flexible. So they're not just designed for one service. There was a big sad story in the US in PJM where they opened the frequency regulation market to batteries. And everybody said, this is great, we can get paid this, and I'm just going to crank down the cost of my battery system as much as possible. They put in all these half-hour batteries, and then there was more of them than they thought. They didn't know all about each other. And then as the batteries came on, they were so good at providing this frequency regulation service, they actually shrunk the market for the service altogether. And they said, well, you can do demand response. And well, I can't. I only have a half-hour battery. It's only good for frequency regulation. You end up with a stranded asset. So let's make sure we have flexible assets going out there.
Flexible assets, okay.
Yeah, learning by doing. So let's
by
learn
doing.
from each other and baby steps to get there, test and incubate and scale and replicate things.
And Hamid?
You know, grid intelligence in general provides a lot of opportunities for entrepreneurship, for economic activity, environmental benefits, all those things. And there are risk takers, entrepreneurs who are tapping into that, and there are programs like IRAP that support these type of things. I think those are fantastic, and we need just more and more of them because the market is global, and the solutions are almost universal, and we just can't have enough of them.
Thanks for plugging IRAP. I'll buy you lunch today. So join me in thanking our VPP VIPs.
Okay.
Awesome. There you go.